This one here, it says tan x equals to root 3. We know that value of tan pi over 3 equals to root 3. Now x should be less than 2 pi, more than or equal to 0. Pi over 3 is in this range. Alright. Second can be, we know that tan pi plus x equals to tan x. This formula here, we cannot use this one because it has to be less than 2 pi. This will give me more than 2 pi. So tan pi plus pi over 3 equals to tan pi over 3. If I solve this, this gives me tan 4 pi over 3 equals to tan pi over 3. It means pi over 3 and 4 pi over 3 are the principal solutions for tan x, whose value is 3. Alright, here tan x equals to negative 1 over root 3. Okay, we know that tan pi over 6 equals to 1 over root 3, positive. In that case, negative tan pi over 6 equals to negative 1 over root 3. Okay, look at this one here. Tan pi minus 6 equals to tan negative. So if I write it as tan pi minus x equals to minus tan x, means tan pi minus pi over 6 equals to negative tan pi over 6, whose value is negative 1 over 3. If I solve this, this gives me tan 5 pi over 6 equals to negative tan pi over 6. Now I can use this formula where tan 2 pi minus x equals to minus tan x. So tan 2 pi minus again pi over 6 equals to negative tan pi over 6. If I solve this, this gives me tan 11 pi over 6 equals to negative tan pi over 6. Means this can have two solutions. First one would be 5 pi over 6. Second can be 11 pi over 6. I cannot take pi over 6 because that gives me positive 1 over root 3. I cannot take negative pi over 6 because that will be not in this range. Our range was x should be less than 2 pi, more than equals to 0. If I take negative pi over 6, that is less than 0, which is not acceptable. So solutions would be 5 pi over 6 and 11 pi over 6. Alright, this one here, sec x equals to 2. Can I write this as 1 over cos x equals to 2? If I interchange it, cos x gives me 1 over 2. I know that cos pi over 3 equals to 1 over 2. So first solution would be pi over 3. Second can be, I know that cos 2 pi minus x equals to cos x. So cos 2 pi minus pi over 3 will be cos pi over 3. If I solve this, this gives me cos 5 pi over 3 equals to cos pi over 3. It means second solution can be 5 pi over 3. I can write it as sec pi over 3 equals to 2 and sec 5 pi over 3 is also equal to 2. So that's the principal solution for sec x, where value is 2. Alright, let's solve some more questions on general solutions. It says tan x equal to root 3. We know that tan pi over 3 equals to root 3. It means tan x is equal to tan pi over 3. We know that tan x equals to tan y in case when x is equal to n pi plus y, n pi plus y, where n is an integer. So this would be x equals to n pi plus y is pi over 3, n will be an integer. That's the general solution for tan x equals to root 3. Alright, sec x, can I write it as cos x equals to 1 over 2? We know that cos pi over 3 equals to 1 over 2. It means cos x equals to cos pi over 3 here. We know that cos x equals to cos y in case x is 2 and pi plus minus y, 2 and pi plus minus y, and is an integer. So x will be here 2 and pi plus minus y is pi over 3. Here is an integer. That's the general solution for sec x equals to 2. Alright. This one here it says, for this equation we need to find out the general solution. So can I write it as cos 4x minus cos 2x equals to 0. Now this is in the format of cos x minus cos y, which is minus 2 sine x plus y over 2 means 4x plus 2x over 2 means 6x over 2 into sine x minus y means 4x minus 2x, which is 2x over 2 equals to 0. So this comes to minus 2 sine 3x into sine x equals to 0. Let's take this negative to this side. So this comes to sine 3x into sine x equals to 0. Now in this case, either sine 3x can be 0 or sine x can be 0. Okay. Here sine 3x equals to 0, sine x also equals to 0. Can I write it as this one? Sine 3x equals to sine 0. Sine 0 degree is 0. Same as here. Sine x equals to sine 0. Now this is sine x equals to sine y. Sine x equals to sine y, where I'll write this way. Sine x equals to sine y, where x equals to n pi plus negative 1 raised to n into y. Now let's take up this one. 3x equals to n pi plus negative 1 raised to n into 0. Here y is 0. So this can be completely cancelled. 3x equals to n pi. So x will be n pi over 3. Let's take this up. X equals to n pi plus negative 1 raised to n into again 0. This can be cancelled. X equals to n pi. So x equals to n pi or n pi over 3, where n is an integer. That's the general solution. Alright. This one here, sin x plus cos x equals to 1. I'll write it again here. Sin x plus cos x equals to 1. Okay. If I square both the sides, this will be sin x plus cos x whole square. This is 1 square. This can be sine square x plus cos square x plus 2 sin x cos x equals to 1. Sin square x plus cos square x gives you 1. So 1 plus 2 sin x into cos x equals to 1. This 1 goes this side, becomes 0. So 2 sin x into cos x equals to 0. Now 2 sin x into cos x is equal to sin 2x. 0 stays as it is. Now again it says sin x equals to sin y, where x equals n pi plus negative 1 raised to n into y. Here y is, this 0 can be taken as sine 0 degrees. So I'll write here sine 2x equals to sine 0, means 2x equals to n pi plus minus 1 raised to n into 0. This can again be cancelled. So 2x equals to n pi. So x can be n pi over 2, where n is an integer. Alright, so general solution for x can be n pi over 2 for this equation. Alright, this one here it says find the most general value of x satisfying the equations. We have been given tan x equals to negative 1 and cos x equals to 1 over root 2. Okay, we know that tan pi over 4 is 1. It means negative tan pi over 4 will be negative 1. So here tan x is equal to negative tan pi over 4. We know that tan 2 pi minus x is equal to negative tan x. So this can be written as, I'll write this way, tan x equals to tan 2 pi minus pi over 4. So this comes to tan x equals to tan, if I solve this comes to 7 pi over 4. So here x equals to 7 pi over 4. Let's look into cos x. Cos x equals to 1 over root 2. 1 over root 2 means value of cos x here is cos pi over 4. Cos pi over 4 is equal to 1 over root 2. Now, here value of x would be pi over 4. Now, we need to see that can we get 7 pi over 4 at both the places? Okay, we know that cos 2 pi minus x equals to cos x. So, can I write this as cos 2 pi minus pi over 4 equals to cos x? Again, we can write it as cos x equals to, if I solve this comes to 7 pi over 4. So, x equals to 7 pi over 4. So, in both the cases, we have found value of x is 7 pi over 4. Okay. We know that value of sine 2 and pi plus x equals to sine x, where n is an integer, and value of cos 2 and pi plus x also equals to cos x, where n is an integer. When this is applicable to sine, this is applicable to cos, same will be applicable to tan also. It means this tan x can be written as 2n pi plus 7 pi over 4. And this cosx will also be written as 2n pi plus 7 pi over 4. So the most general value of x can be taken as x equals to 2n pi plus 7 pi over 4. That's the solution here. Alright. Now this one here it says cot x plus tan x equals to 2 cosec x. Find the general value of x. Okay. Cot x can be taken as cos x over sin x, and tan x can be taken as sin x over equals to, this is 2 into cosec x, so I can write it as 2 into cosec x can be 1 over sin x. Okay, so this is sin x into cos x. This comes to cos squared x plus sin squared x equals to 2 into 1 over sin x. This becomes 1, so 1 over sin x cos x equals to 2 over sin x. Sin x goes this side, so this comes to sin x over sin x into cos x equals 2. It's cancelled. This comes to 1 over cos x equals to 2. So cos x equals to 1 over 2. We know that value of cos x equals to 1 over 2, which is cos x equals to cos pi over 3. Cos pi over 3 is 1 over 2. It means we can use cos x equals to cos y, where x is equal to 2 and pi plus minus y. So x would be 2 and pi plus minus pi over 3, where n is an integer. Alright?